Put your tiny out. Yeah. All right. 8.5, polar equations and graphs. So we are tying together with trigonometry. Polar coordinate system is what we're talking about. So the polar coordinate system is based on a point called the pole. Okay. Basically in geometry, this pole is a ray. Do y'all remember that? No, it's just an explanation. So what we call this is our polar axis. Okay. So you have your pole and then you have your polar axis. Okay. From there, you build all your other things. So point P has rectangular coordinates. So your X, comma, your Y, your R, comma, your theta, all of these things that we've been using all throughout the semester. Okay. Point P can also be located by giving the directed angle from the position. So I can tell you the radius and the angle, and you should be able to graph a point, correct? If I don't give you X and Y, I can tell you R and theta. R and theta are our polar coordinates. Okay. So when I tell you the distance from the starting and your angle, that is your polar coordinate, R, comma, theta. So this is important to write. Or not, you know, can. Let's try that. Oh, see? Your polar coordinates of point P are R, comma, theta. Thanks. Thank you for understanding. All right. Okay, so up until this point, we've had an X and a Y. Now we're switching to a R and a thing. Got it? Okay. So if R is greater than 0, meaning that R is positive, then point P lies in the terminal side of theta. Okay, meaning that it's going to be where theta is positive. If R is less than 0, so this is a difference in polar, notice that our R can be negative. Okay, if our R is less than 0, then the point lies on the ray pointing the opposite direction. It's going to be the opposite of where theta would normally be. So if I had R is 1, for example, let's say I had 1, comma, it's not going to be in degrees, it'll be in radii, but 130, then that would be in quadrant 1. But if I had negative 130, it would be in quadrant 3. Does that make sense? Okay, so changing in that R, yes. Now, yes, R is still, absolute value is your distance, but R negative is telling you your location. Got it? The absolute value of R is still going to be your distance. Okay? But whether R is positive or negative, it's telling you where I am located. Okay? These are the things that we need to remember from our previous sections. If you don't remember them, then you should write them down. Okay? If a point has rectangular coordinates x, comma, y, and polar coordinates r, comma, theta, then the following is true. We've learned before that x equals r times cosine theta, correct? We've learned before that y equals r times sine theta. We've used the Pythagorean theorem, r squared equals x squared plus y squared. And we have that tan theta equals y divided by x. Okay, what I want to add here is that knowing that tan theta equals y divided by x, remember that means that it also would be the same thing as saying r sine theta divided by r cosine theta, which is how we end up with sine theta divided by cosine theta. So that all comes together. Mm-hmm. Fingers crossed that this does not look new in any way.
I don't quite remember the x equals r cosine and y equals r sine, but maybe once we do it, get on it.
So basically, when we had those, you were given the radius and the theta, and you had to find your x and y. This looks steady. It was, no, it was beginning, like in chapter 2. Yeah, it was like the very beginning of our unit. All right, so here we go. It says plot each point by hand in the polar coordinate system, then determine the rectangular coordinates of each point. Okay, so here it says P 230 degrees. Okay, so we know that our radius is 2, right? R equals 2 and theta equals 30 degrees. Agreed? All right, so when we plot this, we're literally just graphing a radius of 2. Now, what's different with polar is that these rings are our radii. So each radii means each ring around the circle. Do you see that? So think about it like a Doppler. Have you ever seen a Doppler radar? Okay. It's a Doppler. So 0, then you have the ring that is 1 radius. Then your second ring is 2. Then your third is 3. Then your fourth is 4, 5, and it keeps going, right? The larger your radii, the further out on the point you're going to go, right? So this is my drawing. So if I was drawing it on paper, as y'all know, I'm not the world's best sketcher. Concentration for me to even do this. All right, there we go. And then I know it's going to go out. And I'm radius of 1, 2, sorry, and at 30 degrees. I'll mark this as my 30 degrees. Does that make sense? Okay,
So,
yeah.
So this would be 1 there, like that would be where the 2 is if it was the 1.
So if it said 1, if this was 1, I would be right here.
Okay.
I would be right here. Then 2, 3, 4, 5. All right. So again, as you're graphing, the angle changes, but your radii circle rings do not. Does that make sense? All right. Now we're going to find our rectangular coordinates. To find our rectangular coordinates, we're going to be using our x equals r cosine theta and y equals r sine theta. Make sense? So we have 2 and 30 degrees. So to find our r, you plug it in. Our 2's cancel out. And we get square root of 3. So we know that x equals square root of 3. So looking at the example for x, can you do y? All right, do y. We know we're ready. Why is that? And why is that? There you go. You always know. Thank you. All right, you got 1 for y. Okay, so our rectangular coordinates are square root of 3, comma 1. Yeah. Yeah. Yes. Are we okay? We're safe right now? All right. Ready to go on? We had a take home quiz over the weekend,
Which one was it?
8:42.
Well,
Y'all really ignore my announcements, don't you?
I don't get them.
All right, let's try it as a gradient. Is it gonna change anything? The answer is no, Ghostwriter, it's not. Okay, this is an example of when your radius is negative. Okay, normally, what quadrant would 2 pi over 3 be in? It's 2. And quadrant 2, but because my radius is it not in 2? Yeah. Normally, it's in quadrant 2, but because the radii is negative, it's going to be in quadrant 4. Does that make sense? Okay, remember we said that if your radii is negative, it's going to be on the opposite side of where it normally is. It's going to be reflected, okay? Yes? Understood? So we see why it falls in quadrant 4? It's of the Doppler. Yeah, like the Doppler radar. That's our thing. Submarines and boats and yes, airplanes. I actually didn't know what a Doppler was. Y'all said no, so I didn't like going any deeper. Just let it be. I just let it be. I was like, we'll worry about that later. All right. So y'all are finding your X and your Y. You've already graphed it. Do they look like mine? Yeah. Give it.
So, for, finding the X, we put the angle as in like, the one.
So you're going to put the angle as in quadrant 4. Actually. Because your radius is still going to be. Well, as long as you keep radius negative, you're fine. It'll all work itself out. Does that make sense? If you keep it negative, it'll mathematically.
Oh,
If you keep the negative to the radius, it'll make the opposite side. So for X, what'd you get? So like, 2, perfect. Listen.
oh, I did.
Well, it'll be one.
So you're gonna use. No, you're gonna use the values here.
Oh.
Oh. Because you have that R is negative, it's gonna work itself out. Mathematically, you'll end up getting your district. Does that make sense?
So what's the matter with flipping it out?
It's for graphic purposes, yeah. Yeah, the flipping is for graphic. But you're still gonna just evaluate the same. So think about it as if if I took the absolute value of the R, it would be 4, right? And if I'm doing the absolute value of the R, then I would use the value of the real angle with the reference of 2 pi over 3. And I would still end up with a positive 2.
So you don't use the 5 pi over 3.
No, you're
Okay.
using the values of 2 pi over 3. So what do we get for Y?
So we multiply it, -2. We're
Yeah.
multiplying it.
So -4 times -half is
Oh.
2. What we get?
Where is that -2?
So checking, are we comfortable with R being positive and or negative? And are we okay with theta being in degrees or radians? Yes, good. Hold it. Can I go? No? Oh. All right. Do we need more examples? Or are we okay? This is an example is when it's negative. I just want when your theta is negative. You want to do it?
Same thing, and just,
You just got to make sure that you're going in the opposite direction.
so it's basically the same.
Same thing, you're just in a different, you're going clockwise instead of counterclockwise. But
So
everything
it's-
else is the same.
So if the X is negative, you flip.
No, what are you doing? Huh?
So like if the X is negative, you like flip it. The
You're not-
opposite.
Yeah, so remember when when your theta is negative, you would be going
Yeah.
clockwise. So this is where negative pi over 4 would be. Okay, if r was negative, then it will reflect it to the
Oh.
other side. Make sense?
Mhm.
But your theta being negative just means that instead of going in a counterclockwise motion, you're going in a clockwise motion, which just puts us here in quadrant 4. Yes? Okay, and I'm on my 5th circle. Make sense? So I'm using the point that the value that's here. So we're at 325, correct? What,
315.
315, right part. We're at 315. So when I find the sine and cosine, I'm using the sine and cosine of 315. Make sense? Okay. Okay. So notice all I did was switch it from negative pi over 4 to 7 pi over 4, because that's the value there, correct? And then I evaluate it. I think it's easy to simplify, so it didn't come out pretty.
I don't get to explain.
What is the x value at 7 pi over 4? Yes,
Oh,
yeah, and so is the y value. So our ordered pair would be. All right, yes? Yes,
Never mind, I got it.
you got it?
Yep.
All right, the negative angle just means that we're rotating mid-clockwise instead of counterclockwise. But we're still gonna end up using the values of its coterminal. Make sense? All right. All right, so keep in mind, while given a point on the plane can have only one pair of rectangular coordinate pairs, the same point can have an infinite number of pairs of polar coordinates, okay? Meaning that depending on where it's located and how many times it is, that polar coordinate can be repeated over and over, which is okay. So we're gonna talk about finding those others. So if I have P 3, 140. There are other points that are going to be equivalent to the same P140 here. P340. P3140. So the way we look at this, we have our different rotations around this point. And notice that the levels are changing. Thank you. All right, here we go. So first, same radii, so same radius. We're going to take theta, the given theta, and add 360. Oh, subtract. Right. I told y'all to write it down for me. Very carefully. Minus 360. Okay. The second one is going to be your opposite radius. And we're going to call this theta. I was going theta 1, yeah. You're going to take theta 1 and you're going to add 180. Plus 180. And this will be our theta 2. And then the third thing you're going to do is still going to be, how do I write that? Do I write it as opposite radius again? Yeah, I'll write it as opposite. Yeah. Opposite radius. And this one's going to be theta 2 plus 360. And that'll give you your final one. Woo! That was in my brain. That was like a dusty old file cabinet I had to. That was not fun. Kind of got a headache from it. It's opposite of your original. Over the, yeah. So just to double check that we're right. So to find the same radius, so it's going to be 3 still, correct? So we have P, 3, To find that, we're gonna subtract 360 from our given, which was 140. So we have 140 minus 360. And that gave us negative 220. Yes? Make sense? Now you're on to the second one. To find your second is gonna be the opposite radii, which is gonna be negative 3. You're gonna take what you got here and you're gonna add 180. So we have negative 220 plus 180, which is negative 220 plus 180. Is that not a 2?
How would you get the negative 2?
It's the opposite radius. So your first one is the same radius. The 3 came from here. It gave us, our radius is 3. Where do you see 320? That's a 2.
It's right there.
220?
Where
Oh,
do we get 320 though?
We're not there yet. We're doing it now.
Okay.
140 was given.
do it all over.
Right.
Okay.
Cause you messing me up with like theta 1, like
Which says to find, we're looking for 3 more angles, right?
I know.
Theta 1, theta 2, and theta
Okay.
3.
Can you number and given theta is theta?
I didn't want to number the given theta as theta 1 because you wouldn't be finding your first, second.
But we're still using it.
Theta not.
Okay, yeah. Okay.
Is that okay? All right, so our given is R and theta naught. We're going to find our first angle, our first new theta, right? To find the first new theta, it's gonna have the same radius. What is our radius? What's our radius? 3. To find the angle, it's theta naught minus 360. So 140 minus 360 gives us what? Negative 220. So our first point is 3 comma negative 220. Yes? Now we're on to the second point. Your second point is going to be the opposite radius of your given. What was my given? 3. So its opposite is negative 3. To find theta 2, it is theta 1 plus 180. So we're going to take negative 220 plus 180. So negative 220 plus 180 gives me what? It gives me
Or negative.
negative 40. Yes? Then to find our third, it's going to be theta 2. I'm sorry, still opposite radius. But now it's theta 2 plus 360. So our theta 2 was negative 40. So negative 40 plus 360 gives us what? 320. And now we have all our 3 additional points. I think it's just because it's showing you its reference point in quadrant 1, but the point is right here. It's right here at 3, 140.
Like I get the radius, but
It's pointing that this is the angle right here. You see the arrow? It's saying that this angle is 140 degrees. Yeah. Okay. Yay, nay? Yeah. Yeah, the degrees aren't where the points are. It's just drawing an arrow towards located.
That makes more sense. Okay.
Okay, yeah, totally get you. Makes sense now. Like this is saying, this is not 320. It's saying this circular motion right here leads you to 320.
Okay.
Make sense? All right. That's gonna be the most straightforward way for me to get you
Oh.
to find it. Yes?
The degrees is missing like that.
Yes, I now see what y'all are saying, like, what is happening? Yeah, so follow the line. This right here is -40, right? And then right here is -20, even though it's labeled, -20 is right here. Right? And then you have your 320 is all the way around.
It's negative, just-
Okay? Essentially, the main thing here is that when you look at it, it's utilizing the reference angles also. They all have a reference angle of 40. Think about it as just reference angles then. Every angle that could have a 40-degree reference angle. If the map.
Say,
Give
like,
us one example.
are we just using the,
Well, are you looking at
the data from the previous one that we found? To
Yeah.
get the next one?
Why
Yes.
do you act like I asked a different question?
No, I just said no, I didn't make one. That's what I was just like, no.
I didn't know you made.
No, I built from it. So like sometimes I'll add extra examples in, but I did not add. This one was already long, so I didn't want to add extra examples to it. Yeah, 8.5 was already was a healthy size and data information.
Was that it?
Yeah. No,
Oh, why would you say that?
just to give you a false hope for a second. All right. So it's to determine two pairs of coordinates and the point with rectangular coordinates. So this time we have the rectangular coordinates, which means we have our X and our Y, and we have to work backwards to find our R and our theta. Disgusting. Okay. How do we find our theta? Anyone want to take a stab at it?
10.
10 what?
Like, why over there? It's like-
10 what though?
Come on.
Inverse. We're gonna look for tan inverse.
See, Lupe would have
When she kept saying inverse. She was- All right, so we know that it's in quadrant 2. How do I know it's in quadrant 2? The points. So we can find our radius using Pythagorean theorem. Agreed? X squared plus y squared equals r squared. And we can find our theta by using either tan inverse, sine inverse, or cosine inverse. Yes? All right. So we're gonna find tan because it's easy. It's 1. Make sense? So tangent theta equals 1 over -1, which gives us -1. So we're looking for the tan inverse of -1, which is 135.
Oh.
Okay, the tan inverse of -1 would be 135. Even if you didn't have your unit circle, could you plug that in? It's gonna tell you 135.
Yes.
Yes, okay? That's because it's in that quadrant. That's the only time where your y and your x are the same but opposite sides. Okay, so now we have our theta. What do we have to find after we have theta? Our radius. So x squared plus y squared equals r squared. So we end up with r equals the square root of 2.
It's R.
R equals r squared equals x squared plus y squared.
What we get?
I need r, not r squared. All right. Can I now write my polar coordinate? I have my r, I have my theta. So the answer is yes. So I have 1. And then the easiest one to find is an opposite, right? And just ask for 2 polar coordinates. And do I have them? Yep. All I did was go online. I just found the opposite. It was faster.
Okay.
Did you go?
So all you would have to do is put a negative in front of it.
Because I went across, right?
Yeah, okay.
I'm tired of it.
Hey, how do you feel about going backwards?
I don't know how I feel about backwards.
It's
Yeah.
our last one. Yes, of course you do.
Talking about.
I love how routine you are. Bye. All right. Questions, comments, concerns? At this point, I'm just gonna count our losses.
So we'll be back to that tomorrow.
No.